Hello, everyone, and welcome to the third episode of the StackToHeap podcast. It's sort of amazing that I've been able to complete two episodes of the podcast already. I didn't think that I would commit myself to start a podcast and then start off by doing two episodes in 2 weeks. And now we are going to start off with a third episode of the podcast. I hope it starts to go well in the future as well. And last episode, we had a good tech discussion around Kubernetes. This time, I think we are going to have a very similar tech discussion on data pipelines and solving particular business use cases with ML and data. To do that, we have two engineers from Sahaj, Srimathi and Karun, and they are going to talk to us about a very nice business problem that they have been solving with the power of data, power of ML, and they have been setting up very complicated data pipelines. And along the way, they have been having a lot of fun, but also having a lot of challenges. And Srimati and Karun, would you like to start off by introducing yourself and what work that you generally do at Sahaj, and then we can take it from there.
Thanks, Manoj. I think I'll go first. So my name is Srimathi, and I've been in the software engineering space for around a decade or more now. And I, I started working on it with a software product company, then moved into the consulting space, building products and platforms for variety of customers. I first started my consulting journey at ThoughtWorks, which is where I worked with Manoj in the past. And now I work at Sahaj as a solution consultant. And I touched my 5-year milestone at Sahaj last month. So Sahaj, let me try to talk about Sahaj a little bit. Sahaj is a tech advisory and consulting company. What we do is we focus on building strong backends and creating IPs for our customers around the world. And very recently, Karun and I have been part of a team building a data product, dealing with terabytes of data and having a lot of fun with it. So today, I hope to share that story with everyone. Karun, over to you.
Yeah. Hi, everyone. First off, Manoj, thanks for having me here. I've been working with Search for about a year. Been working on this on the data pipeline. I think it's super interesting to talk about some of the experiences that we've had. There's some amazing parts about working with a large data pipeline with huge amounts of data, but there's also obviously commonly made mistakes. There's pitfalls along the way, and I'm hoping to share some of that today so that we don't so other people can hopefully learn from some of this and avoid falling into some of those traps. I guess a bit about me as well, which I forgot to mention in my introduction. I've been working for about 10 to 12 years in this space. Did some product work in the beginning, but mostly focused on services since then. Working with clients from all around the world, trying to help build large scale systems and solve business problems for them.
Hey, welcome, Srimati and Karun, and definitely thanks a lot for taking the time out of your workday and whatever is happening in the world to come and talk with me here. So, with the introductions done, so when I heard about the initial brief summary of the problem that you're trying to solve, I was very excited about it, and that's the main reason that I wanted to talk to you folks about it. So, would either of you start off by talking a bit more into the detail on what is the business problem that you're solving, so that sets the context on why you had to do things in a certain way and how the problem is being solved?
Yeah, sure. So the problem that we worked on, the industry itself is ad tech and advertising technology. And our goal was to use data to do ad targeting to the right user, which is what is meant by that is that the money spent by advertisers is most effectively used, and the ad is relevant for the users. They see what they're intended to see. So these ads are not digital ads. I mean, not the ones that we see on the internet, but ads that go on billboards static as well as digital billboards around the world. And how to target the right user to see the right ad at the right time. This is sort of the multidimensional problem statement. And how can we, data being the new oil, can I say that still? I don't think so, with oil prices dropping. But so
there was also this joke going around that people are storing too much of data now, and they want to give the storage to someone else as well now, which is also the same problem with oil. So it's still possibly valid.
Yeah.
A lot of folks have a lot of data that they don't know how to put it to use, or even struggling to store the petabytes of data that they might sometimes have.
And working with glaciers, melting them, and whatnot. Okay. So in our case, we procured user data from the marketplace, where we could get user specific data, their location information and things like that. And we use ML to understand this user behavior. That is, we like to call it location intelligence, where we understand the kind of places the people go to and try to use that for the problem statement we have, which is ad targeting. And for example, do the users like sports? Then the sports ads need to be where they are most recently, wherever they are seen. And and the way the problem itself translated it to something called audience segmentations, where you want to try to segment these users into different buckets, so that you can try to work with different user behavior and try to get as niche as you want, or as broad as you want, depending on the brand that you're trying to advertise. And and this helps us get to the best places and the best time, best hours in a day, weekends, weekdays, holiday seasons, where best to position the ads. That's how the data really enriched this goal, that the business goal that they had. And yeah, that's kind of the problem that we were solving.
That sounds very interesting, like both fun and challenging. So, how did you start off with attacking this problem? Did you start off from scratch, or did you have a existing system in place? And how has it evolved from the time that you started working on it?
Karun, do you want to give a preview?
Yeah. Yeah. So what is kind of interesting. So when we first came onto the project, there was already a solution which had parts of what we wanted. There were a couple of challenges with the system. The challenges were we were using a sort of so the older version of the application kind of used a database where you pump all of the information in, and essentially you can run a query after that, kind of like SQL. You can run real-time queries, location-based queries, and it'll give you answers. Now that system kind of does its job well, but so sort of cost to value benefit is not that good, because it is really expensive to run. So the problem is that for it to do sort of point and polygon queries, which is did this person actually show up to this place, if you want to answer that kind of a question, it obviously needs all of that data, and then it tries to then it sort of runs a query real time. And for it to do this, it uses GPU based instances, so that it is more efficient. GPU instances are pretty expensive to run, so our sort of runtime cost of the overall system went up. Also, the software in itself has a pretty hefty licensing fee, so the cost goes up there as well. The overall effect of this is that the business was paying a lot of money just to keep the system alive on a day-to-day basis. So if you made 0 sales, you have like a pretty huge OpEx either way. So we wanted to move to a slightly different system where, if I were to take an analogy, it's kind of like being in the food service industry and you're trying to place an order at a restaurant. Now, when you place an order, they don't cook everything from scratch just when you place the order, because if they do that, if they go out, get vegetables that they want, actually chop it up at the time, clean it and actually serve it, it will take forever. So a more efficient way is for them to prep all of the food and then just sort of cook it when it's required. So if you were to apply that analogy on sort of on this scenario, it doesn't make sense for you to have the raw information in the data set and then try to query it. If you prep the data already, it helps reduce the overall time and cost. And if you're doing similar queries again and again, you're not redoing the work again and again. So you're paying lesser overall. And so what that meant for us was to move from a more real-time system where data is coming in, because data comes in batches for us. But if we queried it every time, we are paying more for it. We moved to a more sort of offline batch processing. And then the last mile was actually done real time. So based on whatever queries you have, that still executes real time, but 90-95% of the work is already done in the background by that time. So that helps us sort of move a lot quicker. So that's been sort of the transition of the system since we started working on sort of the new version of the product.
Talking about the word data pipelines, what we have actually built is a pipeline through which data flows, data gets transformed, data gets used to build models, and then finally the last mile that Karun was talking about, which is get queried to answer and produce business value. That's sort of like the full picture of the solution.
Cool. So whenever we talk about a data problem, right, and I've been working on a bit of few systems involving ML, working with data. The biggest challenge for me, apart from like the operational aspect of it around getting the data, handling bulk of data, but the biggest problem has always been how are we measuring the system that we are trying to deploy and solve the problem, and what are the right metrics to track, and how are we measuring our system against those metrics, right? That has always been data quality of our system is performing, monitoring that continuously, getting the feedback in, right? That for me at least has been a big challenge, and that still seems to be something that is largely unsolved, especially getting the feedback back, keep on like improving the system. So how did you tackle the problem around metrics and evaluating the system?
It's an excellent question. So this is something I think every user story that we play when we're writing the acceptance criteria, we're all like, okay, so we finished this, we somehow solve it. How do we validate it? How do we know if it's right? I mean, that's like it goes down to even a story level where we think about it, and at the complete system level as well. And what we've managed to do is a couple of things, which is data quality. We'll try to circle back to that, but from a validation of a model perspective, we have tried to the results of every pipeline are made available to the business users. Whatever said and done, they are the ones that work day in, day out with the insights that are generated out of these models. So we try to give them, I mean, in the product, there are ways where known questions, we have answers built, but when you're building a new model, which is, you're trying to find answers to a new business question, we try to have the intermediate steps visualized to them in the form of, it could be just a way to query the data using some visualization tool such as Superset, where Superset is a Apache library which helps you get powerful visualization and charts, which is integrated with a bunch of data providers, including the one that we have, which is we have S3 as our data lake, and Athena works well with the way we store the data in S3 in Parquet format, and we have Athena queries which tied to Superset now brings out this data, the data output by every model, and we let businesses play with it, understand what these numbers even mean at an aggregated level, at a drill down level. We try to get some confidence from that. I hope that is relatable. And the other angle is the actual business measures, which is in our case, the ad campaign that went on to a billboard. How did it measure? What are some of the business metrics that really matter? Did the campaign really reach its intended audience, the audience that you put together? Did the boards where you put the ad, did they generate enough impressions? Very similar to how a digital ad is, where you can try to have clicks to understand how many people are impacted by an ad. We have similar metrics here as well, where how do people visit a brand after a campaign? I mean, this could apply to the brick and mortar stores very easily. For other cases, that's still a challenge that we are trying to figure out different ways to solve. So we have metrics that are used to determine whether every campaign is effective or not. We try to come up with some of those numbers. We try to go back in time and understand them. We do a year-on-year comparisons. That is, last December, this was the behavior. This December, this was the behavior. Does it tally up? Is there a trend? That sort of things is what's been done.
Okay. One question I had here is when you were talking about campaign effectiveness, right? So did you have to do sort of like A/B testing while rolling it out? And more importantly, when it didn't perform well, what did it involve to roll back the system, right? Or what was done to tackle a case where something went wrong, the campaign effectiveness was what was expected? How does it look like to roll back something like that in a data pipeline system? Like, Could you talk a bit about that?
Sure.
Interesting.
Like,
Yeah, sure.
I can take that. I think that's a pretty interesting problem to look at, right? Like, so the problem, so kind of like experimentation, right? If it's a one variable problem, it's a pretty easy one to solve. If you say that this is the only thing which has changed in the past month, which is your code or your model, then you can say, we screwed up. We probably made a mistake here and we need to roll that back. That's generally not the case, right? Because if you're putting an advertisement, like there's a bunch of things which could have changed. The weather could have changed and people are just not stepping outside. The creative itself, which is like the content of the ad in itself, can change, which changes effectiveness. It could be the model, right? Like the model started giving data which is not that great because we're doing deployments all the time. That could be the mistake. So it's an interesting ask trying to like find exactly what went wrong. Some of this stuff happens outside our system in itself, which is by sort of the folks who run sort of the system. They actually have, for creatives and everything else, they do A/B testing in like there itself. So they actually do surveys. They try to make sure that the content is actually tuned correctly. So that at least helps us wade out some of these variables. And then after that, we sometimes look at our data, because if the so-called effectiveness on our result might go off, one of them might be it's either us that we changed the model and we made a mistake, or that the data itself changed, which is sort of the continuous monitoring problem that you were kind of alluding to, right? Like, because in every other system, it's just the code which changes, and there's sort of if you look at the system as a function, if you put code being static, if you give the same input, the output's always the same. But in our case, because there's a second input, which is the data, and the data changes every week, like there's multiple reasons why it could fail. So we then have sort of data quality monitoring for every one of our key metrics. So version 1 of our monitoring was we have superset dashboards which kind of do trend analysis, which say, hey, here are the key metrics that we know affect our models, and therefore we are monitoring it week on week. So anytime the result kind of goes off, we go back and look at the model. It has happened a couple of times where numbers have started looking off, and the monitoring helps us understand either we've made a mistake or the data has started changing. So that's how we generally tend to narrow it down. Version 2 of this, in terms of monitoring, which we can get into details later, is there are libraries which will help us kind of make, like we want to make it part of the data pipeline itself. In the beginning, we didn't do it, A, because of just like timeline pressure, but B, also because we weren't absolutely sure what the threshold value should be, because it's kind of dangerous to say, I know I should get this much data, but what should that number be? Should it be, let's say, is a 5% change in that week on week okay or not? Or is 5% too much or too little? We didn't really know that. But once we've looked at, like, now we have data for about a year and a half. That's enough to extrapolate some of those insights. And we have a pretty good idea as to what defines a stable system. So we're starting to put in those validations into the pipeline. So now, instead of being reactive, where something breaks and then the business finds out about it, now while the pipeline runs, once these features are done in the next couple of weeks, we will actually break the pipeline ahead of time. So we'll get an alert saying, hey, something went wrong. I'm going to stop processing right now. And so we can have a conversation with the business. And if they're okay, we will just do an override and continue. That's sort of the way we are thinking of going forward with this.
Which leads me to my next question, which I would probably think as the most important question that I plan to ask to every guest that comes on the podcast, because I mainly want to understand what people are doing, but also how they are solving it. What are the challenges that they are facing? So yeah, which obviously the next question is, what were your main challenges in trying to do this? And while talking about it, maybe you can delve a bit into the details of the setup as well.
Yes, there's a long list, right? Because like any large project, there's so many moving parts, and all of them are prone to failure if you're not careful, right? So let me go over sort of some of the setup first, so it kind of make like some of the challenges that we had actually make sense. So earlier we were using a database, like I mentioned. There's a software called Kinetica, which is a GPU-based database. It is being used in like really massive systems, but as I said, like the license cost is pretty high, and the sort of the instances that you need to run, the GPU-based instances, are also expensive. And if you can afford that and you have a requirement for it, absolutely go for it. But in our case, it wasn't really used to its fullest potential. So we sort of moved away from that. And what that meant for us is to have sort of a data pipeline, which means you need something to actually process the data. In our case, that processing engine is Spark, which is, been around for a while. It's really stable. It's pretty good understanding of how, what are sort of the good practices to sort of use there. The other bit was once we have a bunch of sort of data processing jobs, we need someone to actually run it and coordinate it. So we need someone to sort of coordinate and run it. So for this, we use Airflow, like Srimathi mentioned. Apache Airflow is a open source product, which is available. You can run it for free. I think it was built probably by Airbnb and then became part of the Airflow Apache project.
Yeah, that's right. Yeah.
So yeah, it's a pretty common software around. So you can use it as a job scheduler, but also it has a concept of DAGs, which is essentially you can give a bunch of tasks and just link them up saying, do this first, then do this, and then do this. And they can either be triggered by time or they can be triggered by some event happening somewhere else, right? So we use that to run our Spark jobs. The other bit is where do you actually run the jobs, right? Based on the organization you're in, you might either have like a cluster running full time, which is pretty common if you're in enterprises. In our case, because we were sort of a cloud native application, we had access to AWS, and AWS has something called as EMR or Elastic MapReduce. So we use EMR to be able to as a runtime. And so what most organizations do with EMR is they have one cluster running all the time, and they will submit jobs to it. And based on what you're running at the time, you can either increase or decrease the size, and hence the elasticity. But in our case, we go a bit different. From Airflow, what we do is we spin up a cluster every time we need it. So when there are no jobs running, because we don't have jobs running 24/7, most of our jobs run for a short duration of time and then sort of stop. So it made sense for us to not have a cluster running at all. And so every job spins up its own cluster. And this gives us the ability to sort of tune it just to what that job needs in terms of we have like a rough volume of data, which doesn't change overnight. So we have a prediction of how much horsepower we need in our cluster, how many CPUs, how much memory, etc., how much disk space, etc. So based on that, we sort of size the cluster and we start it up. And all of this configuration is through code, so you can change it quite easily. Now that the sort of the setup and infrastructure bit is out of the way, one of the challenges that we had was just around sort of managing cost and also just using some of these managed services, right? So while AWS has done like a lot of heavy lifting for us, just because there's a managed service doesn't mean that like everything was taken care of and everything was easy. There's a lot of plumbing that you need to do in the middle to make sure that it works well for you. So for example, you can use EMR, but by default, if you run on demand, the cost is on demand instances, the cost will be very high. So we move to Spot, right? And some of these are very standard practices. So we moved to Spot. We kind of also we had challenges with sort of the EMR setup itself, where when you start up an instance, you have to install some of the dependencies. And so one of the harder things for us was we were doing pip installations because some of our jobs are based out of Python, and pip meant it had to actually reach out to the internet to get the dependency every single time, which you think would be pretty effective. But about once a month, a cluster would fail just randomly with like, we didn't know it was because of this. The cluster just wouldn't start up. And we didn't know why it was. And it was like pretty annoying, to say the least. At middle of the night, you have an alert saying something went wrong. And eventually we found that it is pip, and the internet connection or the pip server sometimes just drops requests. So the recommendation is you sort of download artifacts, you sort of package it, and then you put it on S3 so that you're actually installing off of S3. And which is a very simple engineering fix once you find it. But the problem was essentially tracking down what the problem was took us a fair bit of time. So while all of these sort of things exist, the other bit is also about how you sort of manage logs on these large clusters. So EMR will put the logs in S3 quite easily if you needed to, which is great for archiving, but it doesn't really help you read them, right? So in the beginning, we were using Logstash, which someone else on the account had already set up. Another team was using it, so we started pumping our logs there. But some of our jobs produce about a couple of gigabytes of data. So overnight, you just had like we shot their entire disk down and we caused failures. So they started getting production page alerts saying that we killed their system, which is a bit annoying. And we realized that using something like Elk also wasn't efficient for what we wanted to do, because Spark's logs are not super readable. And there might be like an open source product which will help us sort of get to better insights, but we like very easily within like 20-30 minutes of like hacking something together, we built a script which helps us parse that logs very easily, because some of our larger jobs have like 400 to 500 log files, and parsing through them and ignoring the stuff which is not really a problem and finding the ones that you do became a bit of a challenge. So we just set up simple filters, filtered out a bunch of them, and there's like a very small shell script which we'll probably open source soon, which kind of helps do some of this stuff. So we had to come up with some, like each of these is like a bespoke solution, and some of these will be open source so that people can use it. But like that was one of the hardest parts of sort of engineering challenges with running a data pipeline is, like you said, like there aren't a lot of eyes on this problem yet. So there's a lot of tooling which is yet to be discovered or yet to be built. And if you're building a data pipeline, a massive one, these are some of the things that you might have to get into.
Great, yeah. Yeah, go ahead.
Sorry, there was one, maybe a couple of other things was just like monitoring. It took us a while to figure out how to do monitoring effectively on our cluster. So version 1, when we built our first set of jobs, we wrote it, we tested it, everything looked fine, right? But what happened over a period of time is the data landscape in itself kind of shifted a bit. So so which meant like if the volume suddenly started doubling up, you wouldn't know if your job you wouldn't know if your job is actually efficient or not. So we started looking at one of the other things we started doing is we use Ganglia, which is a feature which is available inside EMR, where you can just enable it very, very easily. But we started using that to monitor the clusters. Now, one of the problems with Ganglia is while the cluster is alive, it gives you all the metrics, and most people use EMR that way, right? They have one cluster and they scale it up or down. But if you kill your clusters like we do, it means your Ganglia reports also go. So we started introducing like a small cron job, a simple fix, a cron job, which will take the Ganglia report every 2 minutes and start exporting it to S3. So at least when the cluster dies, we have, if it died in the middle of the night while a job was running, you wake up in the morning, you have 2-minute snapshots of your CPU, RAM, all of the key metrics. You at least have some, visualization into it, so you can make an inference as to what went wrong. So like small solutions like that really, really helped us kind of make the system stable. This is like, it took us for like a couple of months to actually learn the tooling that we had to build around this.
Yeah, a couple of comments that I had around this was hearing the issue that you had with pip install, right? I think once we work with big data clusters, distributed systems, right, it's often the simple problem that comes across and gives you a lot of headache, and it also takes a lot of time to even figure out, okay, oh, this was the problem in the first place, right? But that also highlights like a lot of the cases when you are thinking about it, a lot of the problems can be solved in a simple way. Like instead of going ahead and thinking about very complicated solutions, a lot of times you might have to just sit back and then think what the problem actually is and then just solve it in a more simpler way. I think that's something that I have learned as going more into big data, running Spark jobs, doing distributed systems, right? Think simple, solve the problem in a simple way, don't complicate it. The system is already complicated enough for you. Yeah, that's one comment I had. And the other comment, which also ties to the reason that I'm doing this podcast, is whenever we do something like this, right, we always have to do a lot of small jobs that we are sure that someone else somewhere has done it. Somewhere has done it. Someone has even published an open source project for it, which we might not have discovered yet. And finding that itself might be a big challenge in itself. So hopefully by doing this podcast, and I'm sure a lot of folks are doing much more bigger podcasts and all that and sharing articles and so on. But at least this can be like a platform for people to share some of the small problems that they are trying to solve. A lot of us are doing very similar work, and a lot of us are solving the same set of small problems beyond whatever is provided by the tools and open source projects, right? So I would like to see this platform and a lot of other platforms like blogging and writing a lot more, right? Is sharing a lot of these small learnings, small solutions that we have, so that we can all reuse it as much as possible. Those are the two comments that I had hearing what you had to say. So whenever you were saying things around logs not being available, Ganglia having issues and all that, I can go back to last few years where I've solved the same problems in one way or the other, handling spot instances, data locality with spot instances. What happens when one of the spot instances that was having a lot of data goes down and all that, right? Yeah, a lot of similar problems. A lot of them are solved in the open source community. A lot of them are not. And discoverability of the solutions and talking about this is one of the reasons why I wanted to do this podcast, especially around the local area that I'm involved in, talking to folks that I do know or their contacts, and then start talking about these.
Very true.
Yeah. So I think one request to everyone who hears this podcast, right? Because like you rightly mentioned, all of us are solving these problems on a day-to-day basis. Actually, two requests. One is, if possible, if you've solved a problem which is generic and you think that other people are going to face it, if you can, please open source, some of the small tools, or write about them at least. And second, when you write about them or you publish a tool, please name it such that it is easy to find or it gets Google indexed well. Because there are times when
You mean like when the world's biggest search engine called the language Go?
yes, and it is and it is next to impossible to kind of search for stuff around that, right? If you don't, I mean, there are at least 3 products that I can think of which are named Go, right? Like it's either a language or there's a CI/CD tool which is also similarly named, right? So there's like, it becomes, if it's not named well enough, it becomes really hard to find stuff. We should really help each other by having a unique name and then having like a good description so that it gets indexed well on Google. It's almost like an SEO practice. If we start doing this stuff, I think we can help each other by saving time. We don't want, there's enough interesting problems to solve in the world. Let's not solve the same problem again and again.
Sure, yeah, that's like a very good recommendation. And my strategy has always been open source it first and then see if someone is going to use it. Just open source it. Right?
Exactly.
Even if you know or if you feel that someone else might already have done it, it's a very simple problem, but maybe not. Maybe someone will find a use for it. And definitely it doesn't work out for everyone. It does take a lot of time to, even some company policies don't even allow it, or you have to do something a lot of work to even get the code out. So it doesn't definitely work for everyone, but if you can, you must. And just don't think about who's going to use it, who's going to need it or whatever, but just do it. Yeah, it's almost like blogging also. Sometimes, a lot of times I blog just so that I can remember it 2 years down the line. So you can even think of it in the same way or make it like a practice. Yeah.
Yeah, I think that's an important thing as well. Blog for yourself, and I think open source for yourself as well. Like,
Yeah.
at best, right? Like 2 years later, you will not remember how you solved the problem. I think blogging, right, like making code open source, etc., makes it easier. Or think of it this way, that there might be another teammate that has that question. They'll come and say, "Hey, you solved this before. Can you solve this again?" And you'll be like, like, do I really want to spend that time? Or maybe I can just give you the link and you can solve it yourself, or you can use that tool or whatever, right? Reusability is I think a huge thing.
Can I continue on the challenges? The list is still big, so I have a few things to add as well.
Yeah, go ahead before we go off the track more.
So sophisticated challenges aside, we've made some rookie mistakes as well, so to speak. Like, for example, so we have multiple jobs that are dependent on each other, and we want the output of one to be available before the next one kicks in. And the first thing that we went about in the transition from where we started was to keep things on, Monday 4 jobs run, Tuesday couple of jobs run, yada yada yada, and Friday we reserved Friday for our toughest job. Okay, the one that was the most complex, took the max time, max money, everything, and had max business impact as well. And that was on Friday. We chose Friday, and I remember weekends being gone trying to get that back alive and pumping and getting everything to go green. And that was something I remember Karun just went in one day and said, "I'm going to change the whole schedule. I'm getting Friday out of here. I'm getting all our Fridays." Simple, such a small problem, but it had a tremendous impact on the team. So yeah, those are small things too. I mean,
I've not worked a weekend since. Like, since the day I was on support. I had to work, like, fix something on the weekend. I was like, you know what? I'm never going to do this again. Schedule change. Never worked on the weekend since.
So we just crumped the schedule together, and it's worked. I mean, it's such a small change, but then common sense, I guess. That was one thing. And the other thing was with a data product, you're trying to come up with new models. You need a playground to build the POCs, churn the data, build the data. So what we did around that is have a easy way to spin up manual clusters. That is something that we did some tooling on top of what AWS provides. But what a challenge where we faced there was costs suddenly started rising. When people were exploring things, they were starting clusters but failing to terminate them. Very, very simple, small discipline thing, but that went for a miss. So what we had to do was more tooling, which is have things like when the cluster starts up, it has an expiration time. There's a way to extend its life. Small hacks put together that really had a big impact on the whole scheme of things. That was one thing I can share. Then the next thing was with building a data pipeline, you are accruing data over time. We get data pulled from sources every week or every day, depending on the provider. And it's been a couple of years of data. So it's long-term storage. So now there's long-term storage costs that also goes with it, which is like a linear scale. It's ongoing, increasing. So the cost to run the pipeline is big. Is it warranted? Are we accessing all those older data? Are we making use of it? If not, why keep it? So then we had to resort to the tiering that AWS has, which is move S3 to different tiers. They have intelligent tiering as well, where your glacier or something called as a deep glacier is really cheap. So we had to use Terraform for each of the buckets. We gave a different expiration policy. That is, this particular data set this is the lifetime of it. So we had to do those kind of things to bring the cost down as well as have some control over the pipeline. But the flip side is when there is the word that I dread the most is backfill, which is you've either found a bug or you're trying to enrich a model to do something one step more. Then you have to go back in time and do it across every week's data because you're trying to look at historical trend as well. So when you're trying to backfill now, you have to melt the glaciers, cause global warming, create higher costs and all that. So that's another challenge that we face, I think, every other day. What else can I think?
There's something around the backfill, right? I think that's a pretty interesting area because essentially what we're saying at backfill is that there was a problem, right? And problems can be of different types. Either we noticed a bug in the data or a bug in the code, and we have to change something. Now, what this means is you're going back in time and you're actually rerunning jobs, which means, let's say it costed, I don't know, $10 per run, right? And you have to run it once a week and you have to run it for an entire week. So that's 52 runs times 10. You're spending $500 in rerunning that, right? That data. Now that's $500 that you have to spend. Now you got to ask yourself a question, like, do you always need backfill? Because our default was we had like a system start date. And when we were sort of a bit younger, in terms of like the system being a bit younger, we had, lesser data. It was easy. The answer was always the system has a start date. All of the data starts on this date, which is when the system was sort of set up. Let's always backfill from there. And that's a great position to have when you have 6 months of data. And it's pretty easy to maintain. Now we're at about 1.5 to 2 years, right? We're closing up on 2 years worth of data, right, that we have on our system. So the cost kind of goes up to do backfills. So when we look at our AWS bills at the end of the month, right, we are noticing like a huge portion of them is just like a backfill because we created a new model. For example, like this month, 50% of our cost is because of backfill, which means the entire system took X and the same amount of money was spent just in creating a new model. And so you've got to really start asking yourself the question, do you want to do backfills all the time? So one of the newer systems that we've started using is the answer to that question is no. We're not going to do backfills, right? And there's an implication to that. The implication is in terms of business, it means that you won't get insights beyond a certain date, and that has to be acceptable, right? So that's obviously a question we talk to, with our business is like, is this okay? Because here's the cost you would pay and here's the value, right? $500 is just a number. So for some of the jobs, the numbers are a lot bigger. And then that's where the business has to say, if it's really important, you'll put in that money, otherwise we won't. The other side of it is also in the way we build models, you have to get a bit more interesting. One of the examples I can share is from like a previous team. I was working on a sort of fraud detection problem in the financial space. Right, similar machine learning data problem. And so banks tend to have, or financial institutions tend to have like a lot of data for long periods of time. So we had data for, I think, 15 to 20 odd years. Like they have historical data just like lying there, and we could run analytics on top of it. Legally they need to keep like 7 years of data. Now if you look at the third aspect, is like how much do you actually need. We noticed that for the problem at hand, we never needed to compute more than 2 to 3 years of data. And there's a bunch of reasons why. How we came to that conclusion is one interesting bit. The other is like, why is that is a business, a domain specific problem, right? So once you come to that number, whatever that number is, you don't really need to keep or process data beyond that, right? So in our case, if for our example, if the data is, let's say, if it says 3 years, it means that you could technically archive everything beyond that and never access, or even delete it if you don't really need it for other use cases. But also for backfills, when you create a new model, you might only have to backfill data for 3 years instead of the 7 or the 10 that you might actually have data for. So we've started using this technique on some of our newer models, because earlier when we did sort of our models used to take all of the data, it was just too expensive because the compute cost would also go over time. That's another thing I should talk about. Like there's two kinds of models that we have. There's models which just take all of the data and just crunch a number, which is, let's say if you have 2 years of data, it'll take all 2 years and then compute an answer. But as you can imagine, the compute cost will linearly go up with time because the volume keeps going up week on week. So your week on week cost goes up. So then we came up with like sort of a second kind of model, which was incremental. So every week we just look at that week's data, produce the result, and then sort of mash it together to get like an overall insight for the year. And then we say, hey, I just need the 6 months of data or a year of data, and I will just aggregate the results for 6 months or a year. And that actually ends up being significantly easier, and your compute costs stay constant. But so using techniques like this, I guess the harder thing is to know what that time is, whether it's 6 months, a year, 3 years, whatever. How do you come to those numbers is a conversation with your business, and to actually look at your data. So it's a bit of data exploration, understand the implication of doing 6 months versus a year versus 2 years, and then make that decision.
A question I had here is, so I'm assuming you have multiple models, right? So are some of them like the whole batch model, which looks at the entire world and then makes and then you build a model and then it can make a prediction, and there will be some incremental models also, right? So do you have both of them currently in place, and if so, how did you have to change your data pipeline to fit in both a batch and also the incremental set of things?
Yes, we have both of them. The older models that we had were batch based. Simply like, so the way the Spark job is built is that Airflow will pass in, if it's, let's say, everything, right? It will just pass in like sort of the root directory. And because of the way we read data in Spark, right? You can essentially just say, here's the root directory and read everything below it and just process it. This was like version 1 of models way in the beginning when you had lesser data. When we moved to incremental, in Airflow, based on sort of the execution date, we just picked up that week's date and then sort of process that information, which is a bit easier. The aggregation was a tad harder. We had to add utilities to say, I want to aggregate X weeks, and therefore here's a logic on finding those X weeks of data in S3 and then crunching them together. But we started adding sort of tiered data pipelines. And so generally we have like a pipeline which runs weekly. And either we will have a stage at the end which sort of munches the data together and aggregates it, or the slightly more preferred way for us tends to be another DAG which can just do the munching. So we have one DAG which runs once a week and produces only its output. And then there's one which also runs once a week, but it takes n weeks as input and then crunches the data together and sort of mushes it into one data set. The latter is obviously more cost effective and also makes it easier to sort of tweak environments. One of the things we've not really talked about is like, if you have one environment, it's kind of easy to maintain. And you could say business needs 52 weeks of data or whatever, right? Or 1 year of data. Fine, I'll process 1 year of data and just maintain it. But I mean, standard development practices, you have more than one environment. So how do I maintain a dev environment and not have it as expensive? Well, if you're lazy and you just copy all of the data, well, good luck, because your cost is now doubled. If you have a dev, UAT, and prod, your cost is tripled. So the technique we've been using is for the pipelines which kind of mush data together, there's like an airflow variable which controls how many weeks of data it actually works on. So the weekly pipelines are then generally cheap enough where you can run them. And then the aggregation pipeline where you're sort of crunching a lot of data, that's where you sort of reduce the amount of data given to it by like engineering it in a way where it becomes a variable you can inject in. Um, so yeah, that helps us reduce costs. And then sometimes you just switch off pipelines that you don't need. Like if a job's been stable, it's been running for 6 months, you might not need it in dev as much. So you just like selectively turn it off to reduce costs even further.
Yeah, so the next question that I had was, I think every team that works on a product will have like their plan for the future, right? So what is your future vision for it? What are some things that you know that your system needs, but you have not had the enough priority to do it? But say there are like top two, three things that you wanted to do, and now the business has decided that these are the high priority items. So what are those for it? Because that gives a lot of interesting answers around how the people that are working on the team within the constraints of time, cost, and roadmap and business features. But given free reins, what will you do? So, what are the top two, three things that you have in mind?
So what we've come to realize it is once a data pipeline becomes a source of truth, reliability matters a lot. So how to get in that reliability, the words that data quality, I mean, we've been speaking about it in bits and pieces, but that is something that we definitely are thinking to amp up because uh, data comes from external providers. It's uncertain. I mean, how it would come is different. The volume varies, the velocity of it varies, the variety varies. Everything you are reliant on an external provider to give you the data. So, and good quality of data is definitely required to produce the accurate inferences if you want your inferences to be accurate and reliable for business. So having a visibility of your data quality is essential. That is something that we're already doing. We do have a dashboard which shows which provider is sending what kind of data every week, how is the distribution, what are the different dimensions it is, how does it look, and things like that. But what we do think we need is to be able to detect anomalies in the form of volume increase or decrease. In considering the times we are in, volume decrease is something that we did see in the system. But so the volume increase is another problem where the jobs need to now scale up to be able to ingest that volume coming in. So if we had alerts on these data metrics, which is this is the data set coming in, does it have all the columns, does it have all the vital things that needs to be present, that is one thing I can think of where we definitely foresee ourselves putting more effort into. And the other aspect is, I spoke to you about a schedule where there was a Friday job and then we had to crunch it together. One other thought process there was, these are a DAG, basically all of these are dependent entities. If we have that full lineage, I mean, that is how each of them are connected to each other. Once there is a green job, then we can trigger the next downstream job. We can definitely do this. This is something that we've pushed away thanks to whatever you just mentioned, which is timelines and things. But that is one thing that we've been wanting to spend time on. Airflow has interesting ways for us to get this plugged in as well. So those are two main things I can think of. Karun, do you have anything? I'm sure you have a big list, but
Yes, sorry, this has been sort of my pet project, like the area of interest for a long time, the stuff that Srimathi's been talking about. So there's like a couple of other things. Actually, around the schedules bit, right? We made sort of a conscious choice not to do the schedule until we have the data quality, because what will end up happening is, so what we do right now is that we sort of buffer the time a bit. If the volume goes up or down, and we sort of accounted for how much time the pipeline tends to take. One of the ways we did that was, because we have runs for a year, Airflow has all of that data in its database. You can go in, take a dump of that, and then sort of calculate averages for a certain amount of time, which is one of the things I did. And then I planned the whole crunching of the schedule was pretty straightforward because you know how much time a certain DAG takes. And then you add a buffer to it, right? Just to make sure that if the volume goes up by X%, which might happen week on week, you're still safe and you're not missing a timeline. Now, in terms of if something goes wrong, this also means that the time between two jobs, like there's almost an SLA, right? So if let's say a job was supposed to take an hour, let's say we start the next job after an hour and a half, which means there's like a 30-minute buffer that you have to recover. In case something goes wrong, you can look at it, you can fix it really quickly, and you have 30 minutes to do that. If you miss that, you have cascading failures. And in the beginning, we were seeing tons of these, especially when like a job goes wrong on Thursday, like there goes your weekend, because like it's going to have like 80% of your jobs are going to be read after that, right? So you might not work on the weekend, but you might like Monday morning, you're still trying to fix the previous week, which is less than optimal because the business is looking for insights on Monday morning. So you're in a rush to fix it on Monday before the business got into office. So like stuff like that for us to avoid, the data quality checks actually help. And then the schedules help downstream as well, because once you have the data quality checks, it will alert you when something goes wrong. What it doesn't do that well is that like the downstream will still break, like because you missed that clock, right? There's a clock, that 30-minute clock that I was talking about, you're still missing that. So you'll still have a problem. But when you move to sort of a rule-based scheduling, which is if upstream is done, then start triggering downstream, you're better off, because then it'll sort of automatically trigger as soon as you fix the upstream, it'll automatically trigger everything downstream. So it's a lot more efficient. The other bit that which is kind of related, but we've not really done yet, is the maintenance part of the system, which quite often gets overlooked. Which is, I mean, as consultants who are obviously building a product for our team, but it is kind of expensive for developers to spend time on support all the time. So the client organization, the organization we work with, they actually have a support team, a dedicated one, which looks at all of the tech. And so they want to like generally try to do level 1 support at the very least, maybe even level 2, before it comes down to, hey, something needs to be fixed. So one of the challenges we had there was, if you turn this data pipeline over to them, to someone who does not have as much context as us, like we've been, like both Srimathi and I have been working on this for about a year now, right? And we're pretty intimately familiar with every part of it. So if anything changes, anything breaks, we can react to it very quickly. It is kind of weird for someone new to come onto the system. Like onboarding is a bit hard, considering the number of moving parts and considering the number of models. So we, like a while back, we built like a DAG lineage image, which Airflow doesn't do a great job of. Airflow does a good job of one DAG, which is X number of steps. But when a DAG has a dependency on another one, which has a dependency on another one, Airflow doesn't really visualize that for you. There is a tool called Apache Atlas that we've been wanting to use. We'd require some code changes to be able to do that. And that's one of the things we want to sort of experiment with in the future. And just, we don't have a great monitoring dashboard. The monitoring solution right now, we didn't really talk about, but the current implementation we have is we get Slack messages every time something breaks, which is quite efficient because we're on Slack all the time and we can react very quickly. But from sort of a business monitoring perspective, it doesn't answer two key questions, which is one, what's broken versus what's running right now. How good is the system? Is it green or red, right? And second, if I want to use the data, because we process data in weeks, the business can always say, I don't have data this week, but that's okay. My query is 6 months or 3 months ago, right? I don't really need the data for this week. So can I just run a query on a slightly older data set? The answer should be yes. How far can I go back? Like how current can I get? If it's only 1 week's worth of broken data, that's fine. So those two answers are a bit harder for us to answer right now. Those two questions are a bit harder for us to answer right now. But with sort of building that DAG lineage, we want to bring in that concept of time to say, if you want, there's like, let's say 6 key data sets that we have, right? Or 6 key models. This model is up to date until this date. That's like a key business metric we've not added monitoring to. So like some of these things we want to get, like make it more up to date, because the business is now starting to ask some of those questions as well.
Closing comments from you two?
Yeah, I have a couple. If you're building a data product, monitor your data. Spend a lot of time doing it, right? It's very easy for you to spend time on building new models. It seems like the exciting thing to do. It's like, hey, I have data. I want to build this amazing model. It'll have these insights. That is important. Obviously, that's what gives you business insights. But like every other project, if you do not have appropriate monitoring, you will have a problem. And if you don't have monitoring in like a microservices project, that becomes hard. Wait till you get to a data project and you build a data pipeline and you don't know what's going on with your data. Because it's not just your system which can go wrong. It can be one null column, which is like kind of mandatory for you. And that one null column can destroy your entire thing. It will be bad if it throws an error. It will be worse if it does not throw an error and produces bad insights. Because once you build bad insights, it is really hard to find why it came in, right? So invest that time, understand your data really, really well, monitor it really well, and invest, I'd say probably like a 40-60 or something, right? Like 40% monitoring, 60% feature building, something of that sort. Because when we started off, we did probably like an 80-20. And now we're sort of doing like 80-20 the other way to catch up to and bring the whole system to sort of a 60-40, which is 60% of our time is building new features. 40% of our time is making sure that the tooling and everything else is appropriate and the monitoring and everything else is appropriate for it. Because it hurts a lot, not just in the time that you're spending, but also in the money that you're spending.
Yeah, one thing that I'm always worried about is if I do random predictions, would that perform better than my model? So that's something that I always worry about. And yeah, I think it makes a lot of sense to be proactive and start measuring, start monitoring, so that, because once you don't do that, the amount of time that you have to spend once the model is in production, once you have everything running, then that becomes a big nightmare, both from terms of trying to figure out what's wrong, trying to push the change, and also from cost perspective, like you talked about the backfill and all that, right? So cost is going to shoot up as well. So yeah, it pays to actually be very proactive around a lot of these things. And I think many of us do learn that the hard way. We go with the project and then learn it. Yeah, yeah, it's a
I
good
have
learning to have. Yeah,
I have a fear similar to that, which is what if you're rewriting the truth? I mean, truth is something else, and then you predict something else. So I have had some of those moments where, yeah, if you cannot validate it well. But yeah, another closing comment would be to learn and collaborate together. I think that's really important within the team, as well as, like you said, with the community where the problem has been solved and lessons can be shared between people, for sure. I think we need to innovate more in our communities. I think that there's scope for more such collaborations between people, for sure.
yeah. Thanks a lot, Srimathi and Karun. I definitely learned a lot speaking with you too on your setup, and I'm sure people listening to this podcast will also learn a lot. And it helps to share the information. So I'm glad that you both were able to take time, especially in current situations, and come talk to me about it. So thanks a lot. Yeah, see you guys.
Yeah, thanks,
Thanks for having
Manoj.
us.
It was
Thanks for
fun
having
to
us
do
here.
something different during lockdown. So,
Sure.
Thanks for having us here, Manoj.
Yeah, see you.
Bye. See ya.
bye. Ciao. Logging off.